Hello everyone. My name is Juha Holkkola, and I'm the co-founder of Fusion Layer Group. Just a few words about the company. We've been around for a long time, and we're actually offspring of Nixu Corporation, which used to be the largest information security consultancy within the Nordic and the Baltic Rim. But we actually separated from that entity as it was listed to the Helsinki Stock Exchange in late 2014. So we've been focusing more on the network side, and we actually come from DDI background, DNS, DHCP, and IP address management. And looking at the customers in the Nordics and Baltics too, we have large telecoms like Telia Company, Elisa, Tele2, others are our customers. So that's what we've been doing in the past. But today, what I was actually going to talk about is more about the future. So if we think about what's been going on in the area of networking and kind of IP technologies, they've actually been very, let's say, the baseline has been quite static for the last 20-25 years. So there actually hasn't been that many changes. If you think about like dynamic mechanisms to assign IPs, for example, that was DHCP, and it actually started happening 25 years ago. And since then, there actually hasn't been that many fundamental changes that would have taken place. That said, what we actually think at Fusion Layer is that as AI gains momentum, and I know it's popular to be talking about AI in connection with anything, but we actually do think it will have an impact on networking. And the big reason for that is we think computing is becoming ubiquitous. And what that actually means is, it's going to be everywhere. And we think actually kind of the emerging trends like edge computing, AI, others, they will actually necessitate new ways of doing computing. And that computing actually will be kind of everywhere, omnipresent, which we think will lead into a situation in a few years' time where it's actually going to be AI agents that will be affecting changes to the networks, setting up new networks, doing all sorts of things of this nature. And so I think basically where we are getting to here is basically the traditional tools and system we've used to manage all this, they have to be rethought. So that basically, it's not enough just to have an existing tool and AI enhance it, but instead we have to change the architecture so that, for example, AI agents can actually create new networks, set up the security services, all sorts of infrastructure stuff. So that's what we think is happening. And actually, as I mentioned, the different things that we are seeing emerging, there's obviously, edge cloud is something people have been talking about a lot. And we actually think that edge cloud will become the de facto platform for AI enabled computing. But there's actually other things that are happening as well. For example, the AI factories, that's actually something that NVIDIA has been spearheading a lot. And the idea is that to the network edges, people will be building new data centers that actually will be the places where the future AI applications will be run. And of course, considering the role of IP networks, the connections between the users and these systems, it will still be IP based, but it will have to be done differently. There's actually also, going back to NVIDIA, but also Intel, AMD, everyone knows CPUs, right? And everyone knows GPUs. But how many of you actually know about DPUs or IPUs? Have you heard of them? No, not yet. Okay, so this is actually the next black. So CPU is for processing things that you do with applications. GPUs are actually intended for fast computing. So if you have like AI and you're processing tokens, you would use GPU for that. But actually DPUs is something that is dedicated, a processor type for infrastructure services and network functions and security services. And the basic idea is that you if you have a computing platform, you split that into pieces, And on the bottom, you have the DPU architecture that you actually have. It's basically the chips are running on the network chips. So the idea is that it's very, very, very close to the network. And if there are things like there was actually some discussion about security and the flows, how much you can process things, how long lists you can have. The idea of DPU is actually you take all that into a dedicated chip, basically, and then you bring it so close to the network that you can do stuff instantaneously. Then it kind of offloads everything from the top level. And then, of course, that relates to stuff like security and automation as well. And actually, to give you a practical example about what's going on here, so I was actually, NVIDIA did a big event in Europe, in Paris. It was in connection with VivaTech back in June. And I actually managed to see some of these babies here, the racks, live. So it's actually quite big a change. So a rack like that, if you see it live, it's basically like any other rack size-wise. But actually, a single rack has more computing power than the supercomputing data centers we had before COVID hit. So basically, there's huge amount of computing capacity in these racks. The other thing is actually, I was even shown this. It's a kind of this 30 kilo copper bulk thing that is actually the backbone. And the purpose of that backbone is to connect all these different chips that are doing all the computing. And they say, actually, what media says is that each one of these 30 kilo copper blocks, it has more capacity than the entire internet core network that we have in today. So basically, inside that stack, you have more than a single data center, supercomputing data center worth of compute, and you have more capacity to move stuff around than the entire internet today. So it is really powerful. And actually, what connects this to the world, of course, you're doing a lot of computing. So essentially, what you have in them is DPUs. And those DPUs, actually, there's 18 plates, and you have to replicate those for redundancy. So you have 36 Bluefield DPUs inside each one of those chassis. And basically, they are responsible for all the infrastructure services. It can be the basic network functions like, or services like DNS, DHCP, web proxies, you name it. Security functions, so basically firewalls, VPNs, SSH, what have you, and then infrastructure services. So it could be like databases, other stuff like that. And so, essentially what is happening right now is it's pretty early in the EU right now. The EU Commission says that of the 27 EU countries, only 13 right now have even started the AI factory journey. So it's starting to happen. But EU Commission is big on driving this development. And they want to fill Europe with these AI factories. And, a single AI factory can have hundreds of these racks. So, if you think about how much capacity there is in any single one of them, it's going to be a fundamental change. And this will happen probably within the next 5 or so years. So then the question becomes, well, okay, so I have all this stuff, I have all this capacity. What does it mean to me as a network engineer or as a network architect or as the guy who's responsible for making sure that all gets provisioned, all gets managed, everything is orderly, everything is coordinated. And of course, the last 5 years, people have been talking a lot about automating IP management. And that is a good start, because one of the key things here is, if you think about a traditional DC, you would have lots of racks with computing capacity. And for these kind of infrastructure services, you have dedicated racks with appliances that you just put in there, and then you go and you configure them. But actually, in the NVIDIA AI factory model, it's all inside the chip. So you cannot access them outside using networks. And so basically, in order to set things up, of course, you need to automate things. But actually, moving forward, just configuring those chips probably isn't enough, because you have all sorts of things that are on the radar. For example, if you have an AI factory, multiple edge sites, what you actually have to do is you span, the networks, or kind of bend them to cover multiple different sites. And all of that, including the security services, they have to be into place dynamically. And so then the question is, well, how on earth are we going to do that? And actually, this is something that we at Fusion Layer have been working on for actually more than about 18 months now. So basically, we actually hooked up with Business Finland. It's actually a public funded research project, and we've been actually doing research around this area, and we've actually filed some patents as well, and basically trying to figure out how all of this is going to work. And basically, what we are now landing on is a system that basically allows three things to happen. One of them is essentially secure zero-touch onboarding of new devices. So what this actually means is, it could be a DPU or an IPU, but equally it could also be an Ubuntu device. But the idea is I connect it somewhere, I power it on, and then it will automatically do the boot. So basically, yes, traditional DHCP, we actually still use that. We'll give it the IP and the configurations, but we will also give it all the, the software updates from a boot server, in a secure way, using, kind of exchanging certificates, artifacts, stuff like that. So the idea is I power it on, and it will get the stuff that you would normally get today from DHCP. But in addition to that, it also gets, the software updates, basically everything you need to have it securely up and running. And once we've got it securely up and running, what you can then do is what we basically have is a service catalog. And the idea is that it's going to be an ecosystem of different services. We've been working with F5 on Nginx, some private 5G stuff, things of that nature. But the idea is that once I have this set up, I can remotely start tracking and dropping stuff on those servers. So for example, if I'm setting up a new edge site somewhere and I don't have access to it, I can simply, place it in a network where the network device has been configured with a certain for a certain VLAN, you basically have a certain IP gateway it will connect to, and then it will get stuff from DHCP, it will boot up, and we have the connection. And once we have the connection, we can actually start activating and deploying new services on it. So basically anything you need for a remote device at a remote site, you can actually do all of the deployment from the service catalog by just doing a drag and drop, and all of that is secure. Then a third point that was actually being discussed in connection with routing, it's basically the observability side of things. So essentially, we also have monitoring ability. So all the devices you have, first onboarded, and then uploaded the services onto, then you can observe them as well. So basically see how they are performing, making sure that everything is okay. So it's kind of this full lifecycle management for these things. And it's basically, we are using open standards for this. So that's actually RFC 8572. That's Secure Zero Touch Provisioning, or SZTP for short. And the idea is that it should be interoperable. So basically whatever we do should be based on open standards. It should be interoperable. And so that's why we have been using it. And actually, just to give you some practical kind of use cases we've been working on. So we've actually uploaded, for example, Nginx into the service catalog, and we've been able to, we had Supermicro is one of our partners, so they had data centers in Netherlands, and we were running our own systems in Berlin for development purposes, and we were actually able to, in the Supermicro lab, they powered on a new device, a new DPU, and actually it got all the settings, software updates, plus Nginx installed, up and running, everything good to go in 30 seconds. Or alternatively, we actually did this with private 5G as well with a company called Kumucore. It's a Finnish startup. So again, we uploaded a private 5G core components into the service catalog. We went to the Supermicro lab in Netherlands. A new server gets booted up. And then what happens is it gets kind of configured, onboarded automatically. And then the entire private 5G core was installed and activated on that device in less than 2 minutes end to end. So it's actually, it is really fast way to do things. And, that's actually, that's one of the reasons why we think something like this is definitely needed in the future is that, if you think about edge nodes, the traditional zero-touch ways of doing things, they are typically done inside like service provider networks, which basically means that it's a trusted environment. But with edge computing, these edge nodes, they will be, all over the place. And you might want to, spin up a new service there and another one there, and then you might want to decommission it. And actually, within that context, you basically have to do the activation over the public internet, because otherwise it wouldn't be possible. So that's one big difference we think edge computing is doing, and that's why we need to do it in a secure fashion. And basically, I said that we've been doing development, but we are actually not alone with this. So Fusion Layer, we are actually part of Linux Foundation. So we are members there. And more specifically, we are part of the Open Programmable Infrastructure Project, OPI. Check it out. It's opiproject, .org, basically. But the companies there, we are actually the only European company within the OP project. But the others we are working with, they include NVIDIA, there's AMD, there's Intel, there's F5, there's Red Hat, there's Dell, a few others. So it's basically kind of, pretty big bunch of people. And they've actually, what we've decided within the OP project is that SZTP is the reference standard that will be used, for this secure booting of this new infrastructure that is programmable in the future. So that is kind of the direction. And I think personally, much like I've been, the first time I started working with DDI, it was in I think 2000. And DHCP back, 25 years ago, it was still very new. It was just, actually, I don't think even the standard was ready by that time. It just got finished a bit later. And I think actually what DHCP did to IP addressing in the early noughties, I think SZTP will do the same, not just for IP resourcing or IP addressing, but the whole process. Whether it's going to be the next 25 years, probably not. The world is moving faster, but I think there will be a big change. And interestingly, SZTP still does utilize DHCP, and it still does utilize DNS and boot servers and stuff like that. So it's actually not something that would have been developed from the scratch, but it's kind of, you could think of it as a new layer that kind of gets implemented on top of the existing standard-based network technology. So it's quite interesting. And as part of this work, one thing we did, because obviously Linux Foundation and OP project is very strong believer in open source. And so what we actually did when we started working on this about 18 months ago, we actually tried to find open source implementations of this stuff. It didn't really exist. There were a few, but it was by no means production grade. So what we actually did was we developed the first world production grade SZTP client, and we open sourced it. So it's basically, we released it under Apache 2.0 license. Anyone is free to use it. It's at GitHub. Anyone can go participate in the development or just, download it and use it for their own use. Anything goes, but it's there. And what we're actually doing within the OP project right now, it's actually quite interesting things right now. For example, we've just completed the validation with NVIDIA DPUs, the Bluefield chip. So that works out of the box. We are actually right now working with F5, Red Hat, and Intel on a proof of concept or a blueprint where, you basically have Intel IPU. Everyone else calls, by the way, DPUs, they are DPUs, except Intel, they call it IPU. It's Infrastructure Processing Unit. So it's Intel IPU that gets automatically onboarded by our system with our client running on top of it. Then once it has got onboarded and secured, we actually deploy the F5 Nginx kind of packages on top of it. And then the Red Hat Kubernetes or OpenShift orchestrator will start operating it. So that kind of gives you an idea of what you can do sort of without actually having to do any manual effort. All of this actually happens automatically. And, if you think about it, where most of the industry is today, then if it's actually possible to, within minutes, set up new, kind of computing nodes basically that have, the required services that, are being configured by automation, then I actually started off by saying that we think API agents in the future, they can be used to translate intent a user gives and then push it into these programmable pieces of infrastructure that will then, on their own, they will actually set things up and, kind of be up and running in a secure manner. And we are not there yet, but I actually think we are definitely moving to that direction. And as you people here, you kind of spend your days with networks, with IP, with stuff like that. So I guess my message really is that that there is change brewing, and it's not happening yet. But we definitely do think that there's going to be big things happening. And with that, yeah, I tried to be fast because we were actually a bit behind the schedule, so I catched up.